Hi, in this video we'll be moving on to a new chapter called Vector and Scalar, and in fact you have learned about the basic idea of this in IGCSE. So let's just do a quick recap on this to refresh what you have learned. For all the physical quantities you learn in physics, they can either be categorized under vector or scalars. So for example, in the category of vectors, you should have learned the idea of displacement, velocity, acceleration, force in mechanics. Weight is actually a subset of force. So that means all other forces could be like tension, reaction force, friction, air resistance, etc. They are all vectors as well. Here there are three kinds of field: electric field, magnetic field, and gravitational field. The idea of field basically is referring to how a certain substance will interact with the force itself. So a measurement of how strong that force is within that space, then that will be electric field, magnetic field, and gravitational field, referring to electric force, magnetic force, and gravitational force. We'll learn about these things in IB physics later on. And also there are other things that you learn, like momentum, for sure that you know it is vector. However, you will find out the physical quantity, area, under the column of vector. So that means when you are trying to measure the area of something, let's say a square with 3 cm and 3 cm, that means 9 cm square. Is that really a vector? Is my life a lie? Of course not. In physics, there is a reason why we might need to get the area to be vector. Of course, when you are talking about the area of a 2D square, then of course we don't need to make it as a vector. However, there are times where we will need to care about the direction of the area. And that is to say, for example, when you learn about electromagnetism in IGCSE, you may know that when we have a coil, and let's say there are some B field going into it and changing, there might be some induced current. However, the direction of the area and the vector of B field, magnetic field, would matter. For example, if it is perpendicular, then it is when the induced current will be biggest. If it is tilt, then of course the amount of induced current will be less. However, there are times where maybe the B field doesn't change, but then the area change, right? So area actually has a direction also. And that's why we have to name area as the category of vector. If you don't understand what I said about the area direction yet, it's okay, you'll get to learn this later on. Next is angular velocity. Same, if you don't understand this, it is fine. But the basic idea of this is something we will talk about in the circular motion in the later chapter. And it's also describing how fast a thing is rotating. And talk about rotation, you may be thinking of moments that you have learned in IGCSE, and they are kind of similar, but then of course it's not the same thing. When you describe a certain moment, you will talk about clockwise direction or counter-clockwise direction. However, this direction is not the one that we are referring in vector. In fact, if you try to search about it, you can find it very easily. So when we talk about a certain object that is rotating in this diagram, like in this direction, that is, if you view from top, that's gonna be counterclockwise. But then the direction of the angular velocity, we don't say it is counterclockwise. We'll say it is upward in this diagram. So the way that we actually determine is by using the right-hand grip rule you have learned in probably year 10. So if you try to grip the direction where it is rotating, the form is representing the omega, which is the angular velocity direction. So once again, if you don't understand right now, it is totally fine. Even after IB physics, probably if you don't understand this, that's also fine as well. So if you're interested, you can go and check it out, especially if you want to advance your study in university for engineering and physics, then maybe you want to know about this more. Otherwise, it shouldn't affect much in IB physics. Alright, example for scalar, that should include distance, speed, mass, time, density, that I'm sure you have learned in IGCSE. Something called electrical potential. Notice that without the word energy. Similar to gravitational potential. So these things are related to energy for sure, but then they are kind of per something. So for gravitational potential is like the amount of energy per kg of mass. Electric potential is like per unit of charge, which is Coulomb. So again, we'll get to learn this in the later chapter, so don't worry about that. Electrical charge, we have positive and negative charge, but then they don't carry direction, so that's why they are scalar. Temperature, you may sometimes say, oh, the temperature go up or down, but that is actually referring to increase or decrease, right? They don't actually physically go like moving up or moving down. So scalar. Volume, for area, you can talk about it because for area, it has to orientate with certain direction, but then for the volume, you really cannot say about that. So that's why it's scalar. Lastly, for energy, obviously, this is scalar because they don't carry direction, and this is actually the best part of energy. That's why you can simply just add them up together or subtract them together without caring about the direction. Of course, this table is just for some examples only. There are more than physical quantities than we show on this list. So if you are wondering whether a certain quantity is scalar or vector and you don't know the answer, you can Google it or you can ask me in the comment section below. Okay, so back to the actual basic definition of vector and scalar. Like you just heard me, vector will be the one that has both magnitude and direction, while scalar, they don't have direction. They only have the number, which represents the magnitude, or you may call it the strength of that quantities. So in primary maths, you must have learned about addition, subtraction, multiplication, and division. So here we'll introduce to you once again very quickly. I know many of you should have known it already. So first of all, you can actually multiply a scalar to a vector. And when you do that, basically you are changing its magnitude without changing the direction. So for example, if this is A, if you multiply it with the number, which is a scalar, 2, then you're making the length twice as long. Or if you multiply it with negative 0.5, then you did two things in total. One, when you make it as negative, that means you basically make the direction opposite. Just like what you do in mechanics, when you have a negative velocity, that means it's opposite to what you have defined. Next is the 0.5, that means making it half in terms of the length, that means the magnitude itself. Oh, and be careful that whenever you draw a vector in IB physics, different from IGCSE, which is more lenient, whenever you draw an arrow, which is a vector obviously, you have to pay attention to its length because it's very important for you to be aware of that. And when we do the marking of your answers, we'll check the length very carefully. So for example, if you're in an object that is said to be in equilibrium, let's say there's an upward force and a downward force, then you must make sure that this two will be of equal length. All right, you may use a ruler, of course, but at least from the marker, with my eye, I should be able to see if they are more or less the same. Or in a situation where you find, oh, this object is actually falling down with acceleration, so they should say, according to what you learn about F equals to ma, then you should know that there should be a net downward force, and therefore they should not be in equal length. The one that is downward should be longer than the upward force. So that means whenever you draw an arrow, again, the length will be very important. So make sure you pay attention to that instead of just mindlessly draw the arrow. Next, you may be wondering, what if we do multiplication of a vector, not by the scalar, but with another vector? So this will get quite complicated for now and goes beyond the IB physics syllabus. So I don't want to go too deep into that. But then if you're really interested, go and try to search about something called the dot product and cross product, because these are the main two ways of doing multiplication with one vector to another vector. And when you try to express it, you can do a vector, by the way, this is the symbol of a vector, dot b vector, so this is called the dot product, When you do cross product, it will simply be cross, so A cross B. The interesting thing is, when you do dot product, it will be the same as you have the other way around, so B dot A. While when you do cross product, it will be different because it is somehow opposite. So when you do B cross A, they don't equal to each other. Actually, it will be opposite instead. All right, that's something that if you learn about the 3D vector, then you will get to learn this in maths probably, or in the university. Or if you are learning about anything related to 3 dimensions, then you must get to learn the dot and cross product. Okay, never mind. Let's get back to something that is much easier first. So let's talk about addition. Addition is something that you have learned in IGCSE also, and that is to say when you have two vectors A and B, how you can put them together and find out the sum. And the idea is very simple. What you learn in IGCSE is that you were told to draw a parallelogram by translating this vector here and translating the vector A to here, and using the ratio and also the ruler and protractor, and then you draw a resultant vector like this, and then you can use the ratio to calculate back the magnitude of the resultant. If you want to revisit that, I actually have a video about this, so I'll put the link in the description and you can go and check it out. I'll show you how you can do it with ruler and protractor. PHET also made a very good simulation for vector addition, so let's just take a look very quickly. So first we start with 1D, and well, what do you expect? I mean, if you try to pick two vectors together, you can actually find the sum. So this one is the sum, and if you change one of them, then the sum of course will change. So if you have one which is 5, the other 5 go in opposite direction, then the sum will simply be 0. So you can see you just like adding two numbers together. Of course, you can also do vertical, and the idea is the same. All right, idea is the same. I can't do it in 2D in this tab. So let's move on to 2D. So this is how 2D may look like. You may have one vector here and another vector like here, and this is the sum. So there is something called the head to tail method. That means if you want to find the vector of A and C add together, you can actually put one's head into the other one's tail. So it's like connected together. So when you try to, like if you think about a person walk through this vector, then that will be the distance, and the displacement will be from simply the beginning and the end, and that's why the sum will be like here. Okay, and if you change accordingly, then it will all be the same. All right, and if you change, for example, like this one, then yeah, at the end of the day, they will always make a triangle like this. You can also enable the view of vertical and horizontal component. You can actually do other things, but I think this one is probably the best for your learning. And so here, you should be able to evaluate the number as well. So 9.0 is a vertical, and here how you can find out by calculation is 20.1 sine 26.6 degrees, so you can find 9. Similar for 18.0, so that should be 20.1 times cosine 26.6. When you try to combine, that means addition of two vectors together, basically that is what you are doing. You can do, say, let's say this one. But when you combine these two, you can either do head to tail method, or you can also consider this is like you have the horizontal component. So these two are both going to the right, so you add them together, then that means going to the right will be 28. Vertically, you will have the one go up, that is 9, going down as 10, which is negative 10. If you add these two vertical together, that means 9 plus a negative 10. That means 9 minus 10. That means negative 1. So therefore, the sum, if I click this, you can see that I have a sum with the vertical component of negative 1, while horizontal will be positive 28 to the right. So you can do maybe a bit of experiment with this, then you can find out how it changed accordingly. I'll put the link in the description below, and this simulation is now web-based. So that means as long as you use a web browser, then you can open the simulation. You don't have to download anything. Okay, subtraction. Subtraction is very simple if you understand addition. So for example, if you have A minus B, then it will be the same as A plus the negative B. So that should apply similarly in vector also. So let's look at this example. If we want to find the resultant of D minus E in vectors, and you only get to know D and E only, so what you have to do first is to revert the direction of E into the opposite. So negative E is like this, right, going in this direction. And so the next thing is you just combine them together. So just like how you do addition, put these two together, then you'll be able to find D minus E. Alright, in order to test whether you understand the basic idea of vector, please try the question on my screen, pause the video, and I will show you the answers.
A few moments later.
In order to make my answers accurate, I'll be using a ruler to measure the vertical and horizontal components of the vector. Notice that my measurement may be different from yours because it is on my screen. So I zoom in to my screen to do the measurement. If you print it on your paper, it's okay. I think as long as the length that you draw at the end is more or less the same as mine, then it is okay. So let's start with the first vector. So here it is 4 cm. So I'll just say 4. And then for this one, you have to decompose it into horizontal and vertical. Having horizontal should be a bit longer. Okay. And this one is about 1.5, I think. Yeah. Not yet 2, but 1.5. Okay, let's say 1.5. And this one is about 5. So that is to say, if you try to combine all this together, that means horizontally, it will be 2.5. So 2.5 is about here. A bit too long, but here. Okay, and vertically, it will just be 5 downward. So that is to say, the final resultant will be somewhat like here. Okay. But then this is just a resultant, this is just a resultant of these two vectors, but then I ask you to add an additional vector so that the resultant will be 0. So that means you have to reverse the answer of this vector. So that is to say I have to draw something like in this direction. So this one is about 5 point, almost 6, but not yet 6. About 5.8. So I will do around this direction. It will be so good if you have a ruler to help you. So make sure you do it with your ruler. So that's the answer for the question on the left. For the question on the right, it's actually simpler. So what you have to do is, obviously, you can see this is symmetrical. So horizontally, you have a vector going to the left, a vector going to the right, and they should actually be cancelling out each other. So what you should actually care about is how much it is for the upper one. On my screen is about 1.5. And the bottom that too, each of these will provide a vertical component up to here, which is about 5.5. Okay, so there's a 5.5 and there are 2 together, so it's like 2 times 5.5, so that is 11. So 11 minus 1.5 is going to be 9.5 going downward, but then again you want to add an additional vector so that the resultant to be 0. So that means you have to go upward instead. So upward 9.5 is the one you want from the origin. So I would need to do about here to actually here. Alright, yes, this is out of the space. Okay, so this will be the answer. Okay, so I guess as long as your arrow from here pointing to around the word C and T around here, then should be right. And this one go around this position should be right. That's it for now. So in this video, we learn about the basic idea of vectors versus scalar, and also we learn how to do vector addition and subtraction graphically. In the next video, we'll learn about how to do the vector in a more mathematical way. I'll see you again in the next video. Bye.